Hello, is there someone as a host of the meeting?
Hello. There will be a host in a minute, I think. Okay. There will be very soon.
Okay, thanks.
Okay. Başlasam.
Hi everyone. Dear participants, we are now continue with the keynote speech of Professor Dr. Lauri Malmi. Dr. Malmi is professor at Aalto University, Finland. His keynote speech title is Perspectives on Automated Assessment in Computing Science. His research interests encompass, among others, computing education research, especially program and algorithm visualization and automatic assessment in instructor programming and educational technology. The simultaneous translation of Dr. Malmi's speech will be done by Dr. Amanda Yeşil-Bursa. She is professor at Bursa Uludağ University, Faculty of Education. I'm giving the microphone to Dr. Malmi.
Thank you. Thank you very much. So I start with sharing my screen. I hope it works. So do you see my presentation?
Şimdi ekran paylaşım yapıyoruz. Görünüyor mu acaba?
I hope you see my presentation.
Görünüyor. Evet. Yes, I think it's visible. Yeah, I can see it.
Good. Thank you. I'm talking to you today about perspectives of the current situation of automated assessment in computing education.
Şimdi bugünkü konumuz günümüzde otomasyon eğitim nasıl ölçme değerlendirme nasıl yapıldığını söylüyor. Tamam.
And my background, so the Aalto University is the biggest technical university in Finland, and it's formed formally in 2010 by combining Helsinki University of Technology, Helsinki School of Economics, and University of Arts and Design. The computer science department where I'm working is the largest computer science research institute in Finland with more than 40 professors and 400 researchers. And I've been leading the Learning and Technology Research Group for about 20 years, which focuses on technologies to support computing education.
Şimdi Lauri Hoca kendini tanıtmış. Aalto Üniversitesi Finlandiya'nın en büyük teknik üniversitesi olup kendisi de eğitimde otomasyon ölçme değerlendirme ekibinin başındadır.
Yeah. Okay, so my presentation, I will look at the automated assessment, especially in program education, giving a little bit of historical perspective, then what kind of aspects can be analyzed and what kind of feedback is given, as well as showing some empirical findings, and then how to integrate these into courses, including what benefits and challenges there are.
Evet, bu konuşmamızın genel hatları o şekilde.
So here, what I'm focusing on is automated assessment when students are submitting work with structured content. So I'm not looking at multiple choice questions or simple answers like fill in blank questions which are trivial, as well as I'm not looking at essay grading, which is not specific to computing education and is a challenge itself. but I'm looking at the submissions which I analyzed, such as program code or SQL queries, ER modeling, UML modeling, and this assessment can be both formative or summative, and much of this is actually the formative stuff, giving advanced feedback for students.
Otomasyon değerlendirme öğrencilerin şey olarak kodları kullandığı ödevlerine hem formatif bir şekilde hem en son değerlendirme testler, deneme yazılar gibi ödevler ele almıyor.
And the driving motivation of developing these systems has always been from the very beginning to reduce teachers' workload in grading and assessment. And then in the recent years, more focus is that giving immediate feedback and rich feedback for students.
Evet, şu andaki motivasyon hem öğretmenlerin iş yükünü azaltmak hem de öğrencilerin hemen dönüt alabilmeleri için bir motivasyon olmuş.
This is actually a very old field. So the first systems that has been published was already over 60 years ago, but they were rare systems. And in production use, they have been these systems have been used increasing from 1990s onwards, and especially in automatic testing of program correctness. But now, during the last 20 years, it has been growing and widening. So there are new topical areas in computer science, which are where these systems have been applied, and new aspects have been analyzed, and feedback forms have been developed.
Evet, bu çalışma alanının tarihi 1960'lara doğru başlıyor ve en son zamanlarda tabii ki son 20 yılda daha çok büyüme ve ilgi görmeye başladı.
And these two diagrams from recent surveys, they show the growth of the field. So the figure above shows the number of systems which have been published over the years, and the figure, lower figure, is the number of publications identified which address automatic assessment and feedback over time. But there's a clear increase over the last 10 years.
Evet, bu grafikle bu artışı çok net bir şekilde gösteriyor.
The topical areas in computing where these systems have been applied, naturally programming, especially in introductory programming. Then there is database management, for example, analyzing SQL queries and ER diagrams. Web development, which includes naturally programming assessment, as well as how the program is running in the browser. Then various software modeling approaches like assessing UML diagrams, computer graphics, mobile applications, formal languages, automata, even systems administration, operating systems. In these domains, there have been systems developed.
Evet, bu analiz edilen alanlar göründüğü gibi programlamadan, mobil uygulamalarından sistem yönetimine kadar çok geniş kapsam diyebiliriz.
I focus mostly here in programming education, and so the main focus of work has been in introductory programming courses, because these are very large typically. And initially 1990s onwards, there has been the analysis of text programming, so C programs, Java, and so on. But now, during the last 10 years, also visual programming, especially in school level education like Scratch, Snap. There have been tools developed to assess the visual programs. Then there is work in understanding code. So, for example, understanding how students trace code. Do they understand what code the execution process? How well the code has been tested. There's also a target of analysis. Graphical user interfaces, as well as parallel and concurrent programming, are also they have been focused on research.
Tamam, bu hangi programlar değerlendiriliyor? Yani basic temel programlamadan yana son 10 yıllarda görsel programlardan kod anlamadan çok çeşitli alanlarda program değerlendirebilirler.
A few words about the analysis technique that have been here. So in when analyzing program correctness and functionality, the oldest method and actually widely used still is the output comparison, so that the program is giving a set of test data which the teacher has defined, and then the teacher has a model solution, and there's a comparison of the teacher's model solution output and students' model solution, student's solution output, and comparing these against each other. Typically, there have been issues here with formatting, because it can be very strict, the analysis in some systems, so that even a single additional blank in the student's answer might cause the lose points, and that's why there have been various kinds of approaches to mitigate this, like using regular expressions or searching certain strings from the student's output. Unit testing has been used widely, and for example, we are using unit testing in our Scala programming course, where students need to implement, for example, certain functions or methods, and then the actual working of the method is tested with the unit tests. Then there are static analysis methods which build abstract syntax trees or control flow graphs from the student's program, and then compare these to model solutions, similar analysis. There's also work with code quality, so analyzing coding style and whether there are unused variables or code which is never accessed, or then there is excessive object creations, so that in object-oriented programs that they are inefficient. Analyzing various anti-patterns in code quality, and also using software metrics to analyze, for example, code complexity. And also this test development, that how well students have been testing their programs, have been used in the analysis, so that students also submit their test suite, what they have been using, and this is then run against various code coverage metrics.
Şimdi çok çeşitli analiz teknikleri var. 4 ana hatların altında toplayabiliriz. Birincisi programın doğruluk ve işlevselliğiyle ilgili. İkincisi de kodun nitelikle ilgili. Üçüncü de bu test geliştirme ile ilgili. Dördüncüsü ise intihal.
Now, one of the challenges in these systems is security, because we are, if we want to analyze students' program execution, then executing a program which might have malicious goals is a threat. And the simple threat is just that students might try to get the access to sensible test data, so that they would know that teacher's test data is this one, and then I need to just produce these results. But the more serious ones is that these students' programs might use excessive CPU time or access file system and network connections to cause something malicious. And there are various technical solutions have been developed to address these challenges, like running a student's program just with user privileges, or using operating systems facilities like process jails, or mandatory access control to restrict what students' program can do. More recently, virtualization, so running students' program in virtual machines, and especially in containers, has been increasingly used, because containers are various. It's a lightweight virtualization technique, and especially Docker container has been quite popular as a resource for our running students programs, and we are using it in the cloud, so that this is very scalable when there are lots of students are running their programs against the test suites.
Evet, tabii ki öğrencilerin ödevlerini alıp birçok zorluklarla karşılanabilir. Özellikle güvenlik açısından. Birincisi öğrencinin oluşturduğu programı işleve koyarken bir kere öğrenciler öğretmenlerin çok hassas olan sınav verilerine ulaşabilir. Ve daha kötüsü bu öğrencilerin oluşturduğu programların aracıyla malware, yani malicious, kötü kullanımı sebepler olabilir. Tabii ki bu her zorluğa karşı bazı çözümler var. Çeşitli çözümler vardı. Hani kullanım düzeydeki bazı sınırlılıklara process jails dedikleri bir süreç, hapishane gibi ilginç bir var burada. Ama çeşitli geliştiriyor, çözümler geliştiriliyor buna karşı.
Yeah. In a review of various feedback mechanisms by Koenig et al. From US back, they had analyzed over 100 systems published over 50 years using the framework which defined what kind of feedback is being given by the systems. One of these is knowledge about task constraints. So, like for example, hints or requirements of the task, like using a certain programming language construct or not allowing the use it. And then there might be hints on task programming processing rules, so how to approach the task. Then some feedback is about knowledge and concepts, so explanations and examples of the main concepts addressed in the task. And a lot of work has been in this knowledge of mistakes. So feedback on test failures, naturally compiler errors, but then solution errors like the missing functionality in student solution, or that student solution is crashing. Analysis of style issues and also program performance, so that how fast program runs against a certain data set. And then there could be hints about how to proceed, so how to address fixing an error, what would be the next step, or how to improve a working solution. And finally, there in some, though very few systems, they address metacognition, so giving feedback for students about reflecting their own work.
Şimdi 50 yıl üzerinde yapılan analiz çalışmaları 101 sistem üzerinden yapıldı ve bir çeşit, yani 4 çeşit geri dönüt verilebilir, ortaya çıkabilir buralardan. Birincisi bu task sınırlılıkları ile bilgi ile ilgili. İkincisi de kavramsal bilgi. Üçüncüsü de yapılan hataların ile ilgili bilgiler. Şimdi bu yapılan hataların düzeltmesi ve nasıl devam edilebilir ile ilgili bir bilgi ve en son biliş ötesi düşünme ile ilgili bir, yani öğrencilerin yaptığı ödevlerin ve aldığı feedback üzerinden kendi reflection yapılabilirler, yansıtıcı düşünce yapabilecekleri.
And here, just few figures about the analyzing of the systems. So of these 100 systems, and that class 2 tasks, it means that these are systems which analyze just code snippets like that. They're working code, and students need to add a few lines of additional program there. And here, class 3 means that students submit whole programs. And we see that the most of the feedbacks what is giving is about knowledge of, about mistakes, so test failures, compiler errors, and solution errors. And where there is little work and which might be needed by much more in the future is hints about the task processing rules, so how students should proceed, and how could it improve their as such working solution.
Şimdi bu tablodan gördüğümüz gibi en çok verilen geri dönüş şeyin üzerinden yapılan hataların üzerinde verilen dönüt oluyor. Ama aynı zamanda hoca diyor ki daha çok faydalı olabilecek bu task processing rules, bu task süreciyle ilgili kurallara ile bu iyileştirme ile ilgili dönütler faydalı olabilecek diye vurguluyor.
Few words about what kind of evaluation studies there have been. So the simplest evaluation is just anecdotal, so that just teachers' reflections or students' anecdotal feedback on using the systems. More work is there about analytical evaluation. So, for example, systems might be used based on some learning theories or a set of criteria, and perhaps the most important area is empirical evaluation of students' learning outcomes or usage log data so that how they use the systems, as well as then there are various kinds of student teacher analysis or simply technical analysis, that what kind of results these tools generate.
3 çeşit değerlendirme çalışmalar yapıldı, görüyoruz. Birincisi anekdotal, yani anlatım, yani nasıl desem, hani herhangi bir veriye dayalı olmayan sözlü çalışmalar. İkincisi de analytical, yani kuramsal ya da bazı kriterlere göre yapılan çalışmalar. Üçüncü ise empirical, yani veriye dayalı öğrenme çıktıları ile ilgili ya da gözlemler, öğrenci ya da öğretmen anketler ve bazı teknik analizlerden ortaya çıkan çalışmalar.
And these diagrams show that in the recent publications that what has been the most common ways of analyzing, and we see that this empirical analysis here that has been improving. Surveys are more common nowadays, but the learning outcomes evaluations are not so frequent. And what has been a little bit worrying is that many papers don't have, or many systems don't have other evaluation, just like anecdotal evaluation or even no evaluation at all.
Evet, bu tablodan gördüğümüz gibi en çok yapılan çalışmalar empirik çalışmalar, özellikle öğrenme çıktıların değerlendirmesiyle ilgili, ama aynı zamanda hiçbir analiz, bir değerlendirme yapılmadığını dikkat çekiyor.
Now, I moved to some empirical work which concerns resubmissions, because the automatic assessment systems, they provide a valuable practice that students can get the feedback and then revise their submission and then resubmit it again. And this could be done even unlimited times. But there are shortcomings here, because some students misuse this option to resubmit. They use just trial and error behavior, tinkering with the program with some small changes, trying to get it kind of accidentally correct. And there have been various policies to mitigate this issue, like limiting the number of submissions. Very simple one, often resulting that students just ask for more submission time. Or then there's a penalty of excessive submissions, so that if students submit too many times, they cannot anymore get the final the top total number of points. Or that's extended feedback time for excessive submissions, so that they have more submissions, you get them slower and slower.
Evet, şimdi yeniden ödevi teslim etme bir politikası var tabii ki mutlaka bu gibi çalışmalarda. Ama öğrenciler bu bazı sorunlar getiriyor. Bazı öğrenciler bu yeniden ödev teslimi yanlış kullanabilirler. Yani bir denemek için, deneme yanılma için bakalım ne kadar çıkartabilir. Tabii ki bunun önünü kesmek için bazı politikalar da önerilmiş. Bunlar mesela yeniden teslim sayısını azaltmak ya da sınırlı tutmak, fazla yani yeniden teslim etmelerini birazcık cezalandırmak ve bazen bu dönüt zaman verilen dönüt zamanını uzatmak. Hani fazla öğrenci fazlaca yeniden teslim ederse o zaman o hoca için dönüt zamanı daha çok uzun veriliyor.
Okay, here I present some one very recent recently published study where different resubmission policies were analyzed. First, they had a study section one. No, there was no limit in submissions, and they clustered students in the various clusters based on their behavior findings, different types of students, and later on they had another study where they had two the different submission policies. So either limiting submissions or a penalty if the new submissions got much less points than the previous one, which was evidence that students are not improving.
Evet, şimdi burada tabii ki bu yapılan politikaların öğrencilerin davranışlarını nasıl etkilediğini görmek için bazı çalışmalar yapıldı. Birinci çalışmada sınırsız yeniden teslim etme fırsat vermiş ve ondan sonra öğrencilerin bu kümüleme analiziyle bu ödev teslim etme davranışlarına ayırmış, tanımlamış. Bu da bu 4 tane farklı küme oluşmuş. Yetenekli, hızlı, tekrar eden ve boş geçen. İkinci olan ise yeniden teslimler sınırlı tutulmuş ve hatta yeniden bir cezalandırma vardı burada. Hani yeniden teslim edilen ödevler %50 daha az puan alıyor gibi bazı sınırlılıklar getirmişler.
Okay, here just briefly we can see some of the clusters. There are the talented students we can see with the green dots here. So very few submissions and top grade. The ambitions wish to get the top grade, but they use more submissions. And then there are two clusters here which you quite number, even excessive number of submissions, and finally get reasonably good grades. And then small cluster which shows that they don't aim at high, so they are aiming at passing the course. And similar thing is visible in the other grades, whether we compare the grades or with submissions against or grades or regressions.
Evet, bu tablolar gösteriyor, bu küme analizini gösteriyor. Yani yetenekli olanlar, yeşil olanlar görüyoruz ki yani hem az teslim etmekle en yüksek notlar alıyorlar ve en sona doğru 4. ve 5. klaslar çok fazla hızlı olmayan hani dersi geçmek için amaçlanan öğrenciler görüyoruz.
And now this is very interesting because this is an old study from 2006 where I was involved. We used in the data structure algorithms course an automatic assessment system, and we had very similar kind of clusters. So we had talented students. Talented students here with few submissions. When their number of exercises was 29. So they used very few submissions, got top grade. Then we had the ambitions, a little bit more submission for these 29 tasks, but aiming at top grades. And then we had here iterators which use very many submissions for those tasks and not getting very many points. And then we had the passers who did very little and not everyone even passed the course.
Evet, bu diyagramda hocanın kendi içinde bulunduğu bir çalışmanın sonuçları gösteriyor. Çok benziyor bu önceki iki çalışmalarda. Yani bu yetenekli olan öğrenciler gerçekten çok az bir ödev teslimiyle, yani az teslim dediğim zaman her ödev için bir kere teslim etmişler ve yüksek puan almışlar. Ambitious olanlar, hırslı olanlar da benzer görüyoruz ama onlar birazcık daha fazla teslim etmişler. Puanları o kadar yüksek olmayabilir. Önemli olan yine de bu aslında passes yani dersi geçmek amaçlayan, boş verenler değil, dersi geçmek amaçlayan öğrenciler gördüğünüz gibi çok yüksek puanlar almıyorlar ve nasıl desem daha fazla ödevlerini teslim etmişler. Öyle bir benzer bir görüyoruz, tablo görüyoruz.
And when we return to this Lawrence study, recent study, their overall conclusions was there's strong evidence that limiting that alters the students' behaviors. Well, that's not natural. But then that most measures, they favor the policy of setting maximum attempts what students can do rather than giving some penalty of their submission numbers. And also students preferred this maximum attempts policy.
Evet, bu sonuçlar gösteriyor ki evet bir şekilde bu ödev verme sisteminde mutlaka bir sınırlılık getirmek gerekiyor. Ancak en tercih edilen hem öğrenciler tarafından hem öğretmenler tarafından bu olumlu olan hani maximum attempt policy yani en fazla yani kaç kere ödevini tekrar teslim edebilir onun bir sınır getirmesi. Cezalandırması yani regression penalty cezalandırması çok etkili ve tercih edilmediğini göründü.
Okay. Now, just for the time scale, I skip few slides here so that there won't be hurry. Now, let's proceed. That how to integrate these systems with courses. So one of the options is selecting a commercial service which are available, such like CodeGrade or Codio, and then from teachers' point of view, there are no maintenance worries. The service is available because it's company's responsibility. But then on the other hand, of course, there are costs. There's limited flexibility to what the teacher can do with the system. There's a risk of vendor locking, so that if lots of the work has been invested in creating tasks with the system, then moving those tasks to another system might be just too much time, require too much time. And then limited data collection option for learning analytics. Whereas if we adopt an open source system or develop in-house system, then there is much more flexibility. There is no risk of vendor locking, and there's the possibility to build one's own learning analytics to view student progress. And then the worries are that there is always the service break. Perhaps students are running their programs, and deadline is closing, and the system code goes down. And that is a challenge. And then always we need local software maintenance support, and often university IT services, they are not helping here. And then of course the maintenance has its costs. So there are pros and cons in both approaches.
Şimdi bu otomasyon değerlendirme sistemi derslerde nasıl entegre olunabilir? İki yol var, iki seçenek var. Birincisi hali hazırda hazır olan bir hizmet satın almak. İkincisi ise üniversite kendi içinde bir sistem kendi geliştirebilir. Bu iki yöntemiyle hem avantaj hem dezavantaj var. Mesela bu hali hazırda satın alınabilecek bir hizmetse Bu yürütmek için çok fazla dert olmuyor, dertsiz oluyor birazcık ve hizmetin erişebilirlikte çok fazla sıkıntı olmuyor ama çok pahalı olabilir, esnek olmayabilir ve aynı zamanda bu hizmeti satın aldığın şirket belki bir gün kapatıp bütün veriler başka bir yere aktarabilir ve bu öğrenmenin analiz edilmesi için çok veri toplama çok sınırlı olabilir. Üniversitenin kendi sistemini geliştirmesi için gerçekten çok daha esnek olabilir, yeni içerik inşa edilebilir. Bu hizmetin kapanıp başka yere taşımasında bir sorun yok. Üniversitenin kendi öğrenme analiz geliştirip öğrenci gelişimini takip edebilir. Ama tabii ki hizmette bazı bozukluklar da olabilir. Her zaman üniversitelerin teknoloji hizmetleri her zaman yardımcı olamayabilir ve bunun sürdürmek için pahalı olabilir.
So the obvious benefits of this system that they save teachers time grading, and then teachers can use their time for giving more guidance for students as well as developing the learning resources. And there's also that this automatic assessment grading reduces the possible personal biases in grading. From students' point of view, they get immediate feedback and anytime, anywhere, and typically students are happy with that, and then that students can revise their submissions.
Evet, birçok iyi yönleri var, avantajları var. Bu araçla öğretmenlerin iş yükünü çok azaltıyor. Bu ödevleri değerlendirme kısmın zamandan azaltıp öğretmenler daha çok rehberlik verebilirler ve öğrenme kaynaklarını geliştirebilirler. Aynı zamanda bu otomasyon sistemler, bu kişisel yanlılık azaltabilir. Öğrenciler hemen geri dönüt alabilir. Yani yeter ki bir internet bağlantısı olsun ve öğrenciler ödevlerini yeniden düzenleyebilirler.
The main challenges for teachers is that adopting a new tool in use may have a high learning curve, so how to build the exercises there. And then there are challenges possibly how to integrate the tool with other learning resources or learning management systems, or are they just standalone separate tools? And of course, the risk of unexpected service breaks. Students' challenges are the students might try to game the system, to have so that they are not focusing on learning, but they are focusing on getting maximum points. And students might not test their programs properly because they just use the system as the testing tool, and they might carry out trial and error behavior. Students might think that there's lack of collaboration, and of course plagiarism is one problem.
Tabii ki zorluklar da var hem öğretmenler için hem öğrenci açısından. Öğretmenlere bakacak olursak bu yeni bir araç öğrenmesi için çok zorlanabilirler. Bu araçları başka öğrenme kaynakları ve öğrenme yönetim sistemleriyle birlikte entegre etmek zor olabilir ve tabii ki beklenmeyen bazı hizmet kesintiler de olabilir. Öğrenci için öğrenciler bu sistem oyun haline getirebilirler. Hani öğrenme odaklıdan çok ne kadar en yüksek puan alabilecek diye ona odaklanabilir. Kendi programını test etmeyebilir. Deneme yanılma davranışlarda sergileyebilirler. Yani sistemiyle oynamak, bakalım yani meraktan oynamak. Çok bireysel, çok collaboration, çok işbirlik içinde olmayabilirler öğrenciler ve tabii ki intihal çok büyük bir sorun olabilir.
Now, artificial intelligence brings new perspectives to the field, because as you know that tools like Copilot and ChatGPT they have been widely recognized as tools which change the world. So they can trivialize many assignments. That, for example, in a study by Finney and Ashley and et al., they used Copilot as a kind of artificial student, as using the same policy for solving the program CS1 course as assignments. And this tool solved assignments so well that it performed actually better than average students. Then in more complex assignments, this doesn't work, but students might make it a lot easier to use Copilot to solve the programs. And code explanation assignments might get trivial because they just ask ChatGPT, please explain this program. But then there's another thing is that artificial intelligence can be used also to improve learning resources, helping the teachers, so that it can be used to create meaningful new exercises, new versions of similar types of exercises, or it can be used to create code explanations as learning resources, or better error messages for students. And the pedagogical challenge that we see is that how could we compete against the misuse of artificial intelligence, or should we just seek for successful collaboration? And this is something which is globally being thought of in universities, that how to change programming education.
Evet, bu yapay zeka birçok konulara yeni bir bakış açısı kazandırıyor. Birincisi, bu Copilot, ChatGPT gibi programlarla birçok ödevlere basitleştirilebilir. Yani basitleştirmek şey açısından, hani olumlu yönünden değil. Mesela birçok bu çalışma 2022'deki çalışma bulmuşlar ki ChatGPT gibi programlar öğrencilerden daha iyi ödev yapabilirler. İkinci sorunu, aslında sorun değil burada, yapay zeka aslında var olan öğrenme kaynakları iyileştirmek için kullanılabilir. Yani yeni anlamlı etkinlikler geliştirilebilir ve kod açıklamalarda geliştirilebilir. Bizim için büyük olan pedagojik zorluk şu anda, biz yapay zekaya karşı, yani kötü kullanıma karşı yarışmalıyız mı, yoksa yapay zeka ile birlikte başarılı bir işbirlik içinde olmalıyız mı diye şu anda üniversitelerce tartışılıyor.
And finally, some future directions that there could be. So what I see that in the field, that as there are many different kind of analysis can be carried out, but it would be best to combine this automatic analysis also with teachers' deeper insights of student submissions. So this kind of combining hybrid semi-automatic assessment, that the automatic results are given for teacher, and then teacher can then add comments and reflections. Another aspect is how to integrate these automatic assessment tools and the integrated development environments. Like, for example, our students can download their programming tasks to IntelliJ IDE and submit their work there. A big challenge is interoperability, so that's how can these exercises be transferred from one system to another when there are different kinds of exercises, how they can be integrated into one learning environment. Artificial intelligence can be used to improve feedback. And then there's the learning analytics can be used to identify problematic behaviors and address students to drop out. And then one fruitful direction is assessing and giving feedback on program development. So looking at when students are developing a program and analyzing the process, that giving their hints there instead of analyzing just the final solutions. And then challenge is also that how to assess partially correct submissions where students are almost correct, but then it doesn't fully compile, but it's almost complete. Then it doesn't deserve 0 points because of that, but should be understood that how it can be analyzed also in faulty situations.
Evet, şimdi gelecek çalışmaları için birkaç tane yönlerimiz var, öneriler var burada. Birincisi de bu hibrit yarı otomatik değerlendirme için çok zenginleştirilmiş bir destek sunmak lazım. İkincisi ise bu otomatik assessment ile integrated development environments, yani birleşik gelişme çevreleri, yani onların birlikte çalışabilmesi için araştırılabilir. Sistemlerin birbiriyle çalışılabilme, yani çok farklı sistemler var ama birbiriyle nasıl çalışılabilir? Yapay zeka nasıl geri dönüt iyileştirilebilir? Ondan sonra öğrenme analizin bazı sorunsal davranışlar ve riskte olan öğrencileri tespit etmek için kullanılabilir, çalışılabilir. Bu süreç analiz için, yani bu aldığımız geri dönüt, bu analiz yapılabilir. Bu geri dönütün üzerinde analiz edip bu süreç için nasıl iyileştirilebilir? Ve en son hani bazı ödevler tümüyle yanlış değil, yani kısmen doğru olanları değerlendirme nasıl değerlendirilebilir? Yani 0 vermek yerine kısmi puan vererek değerlendirilebilir.
Okay, thank you. Thank you for this opportunity to present some current work. So I'm happy to take any questions. And here are references. I can send the slides to organizer so that you can have the references.
Tamam, teşekkür ediyor Lauri Hoca ve sorunuz varsa alabiliriz.
Evet. Thank you very much. Sesim geliyor mu? Sesim.
So I'm sorry, I didn't expect that there would be a translation here, which means that the scheduling was different that I had planned. But I hope that you got most of the presentation.
Dear Malmi, thank you very much. You accept our invitation to give a speech about assessment, computing assessment. I hope in future we will see you in Turkey face by face, and you will be within the audience, our Turkish researchers.
Thank you.
I also want to thanks to Amanda Yeşil Bursa. She also accepted our invitation to translate your speech.
Okay, thank you.
Now we can ask the audience. Maybe they have some question in the İznik salon. They are watching you in that amphi.
Yeah.
If there is any question, I hope they have some question maybe. Is there any question?
No question.
Arkadaşlar, sorunuz var mı?
No question in the conference hall.
There is no question.
Okay.
It means it is very difficult subject to understand. This issue will take time for our researchers.
Yeah.
Because it is very difficult to think intelligent approaches in assessment. Yeah. I hope we slowly we also try to do some project about this issue to get understand more details about using computing assessment in schools or in other places.
Okay.
For you, what type of abilities our researchers need to use this type of educational technology in assessment? Yes.
No. Well, could you say again? So what aspect of this research you would specifically you are interested in? Could you please repeat?
I am saying now our researchers suppose that our researchers will decide to study assessment in computer, web-based assessment. In this case, what type of underground they need? Is it easy to create their own programs, or they should use the ready programs?
Yes, I would recommend to familiarize first what kind of systems there are as commercial systems available or open source systems, so that they got an understanding that what kind of features are available in different systems and how they could be used. And then if they want to take this further, so that they would like to develop new, then perhaps starting with some open source system might be a good idea. Starting collaboration with some university which is using these systems because or have been developing these systems to get some support for that. For example, in Virginia Tech in US, there's a system called the WebCat, which is used in hundreds of universities. It's an open source system, so familiarizing with that might be a good idea, and then developing a new in-house system, then it means that there must be good software technology background, because these are complex systems with the program analysis and so on. So software technology research is kind of where it's building on.
Actually, many experienced teachers, they are not familiar with using technology in schools,
yes,
or in classroom. Even if you prepare very good programs for these teachers, they are not accepting to use this technology in their classrooms. There is some resistance. These new technologies.
Yes.
What should we do to, especially like in Turkey or other countries, that they a little bit have some resistance to this type of new innovations? What should you recommend for this type of policymakers?
Well, there must be some leaders, so someone who first adopts and then shares the benefits, what can be done, and then there must be enough support services so how to get these systems being installed into the local settings, or that if some server is being used, some service over the internet is being used, but how is it done, so that it's not don't leave it to an individual teacher to find out everything, but there must be support and guidance, support material and online help. So kind of hands-on guidance how to adopt those ones. And when you get over this basic step, then you can see the benefits, and you can see the benefits in your own education, and then one starts liking the systems.
Thank you. Diğerlerinde sor bakayım, diğer gruba soru var mı? Sen de sorabilirsin bir soru.
Soruları tercih edeyim mi? Hocanın sorduğu soruları acaba? Salonda sizin sorularınız var mı?
Bir de sorun var mı? Ben de teknolojide çalışıyorum. Ne? Hocama söyle.
Okay, if there are no other.
There is one more question.
Okay.
Currently, the students are using this ChatGPT type artificial intelligence, but as you said, the teachers are not knowing that much. Do you think is it just a pop of a new trend, or is it permanent? We should we educate our new students in Faculty of Education, or should we integrate the system with these new technologies?
I think it's certainly beneficial if these are integrated into existing learning systems, where whatever learning management system is being used, because then it is part of teachers' normal working environment. It's not a separate tool. And this integration might be readily available, for example, in Moodle environment. Some systems can be added as a plugins, or then there's LTI integration available for some of the systems. But anyway, to make this transition as smooth as possible, so that you can mostly use your normal system and then just add new types of exercises which give certain feedback. That would be good to have everything this set up, and then as I mentioned earlier, providing guidance and support how to use the systems, and perhaps prepare also a set of ready-made assignments, so that teachers don't need to create new assignments, but they are reusing existing ones, so that it's as easy as possible.
Thank you.
Okay, so thank you very much, Lauri Hocam. It's been a great pleasure to host you here. So we'd like to say thank you very much, and I think we will close the session after this.
Yes.
Okay.
Bye-bye.
Thank you very much then. Bye-bye.
Bye. Have a nice day and good luck with your video conference.
Thank you very much.
Thank you.